In this video, we're going to look at the area and volume questions from your test review. Let's start with question number 1. If 0 is less than c is less than 1, what is the area of the region enclosed by y equals 0, y equals 1 over x equals c, and x equals 1? I'm going to start out by sketching a graph of what they've described here. Here's our 1 over x function. I'm going to say this is 1, and I know that c is less than 1 but bigger than 0, so I'm going to put it here. And we'll just say this is our region that we're trying to find an area of. Of course, to find area, we're going to use an integral. I'm going to integrate from c to 1, and my function is 1 over x dx. The integral is, of course, natural log of the absolute value of x from c to 1. And that would be the natural log of 1 minus the natural log of c. No more need for the absolute value because 1 and c are both positive. Natural log of 1 is, of course, 0, and then we have minus natural log of c. And if you look at your answer choices, there's nothing there that matches that, so we need to use a little log property. This is like a negative 1 times natural log of c, and so I can rewrite that as the natural log of c to the negative 1 power. Which of course is the same thing as the natural log of 1 over c. All right, let's look at number 2. The length of the curve y equals sine 3x from x equals 0 to x equals pi over 6 is given by, and then there's a few integral expressions there to choose from. This is, of course, an arc length question, and so we're going to use our formula for arc length. The integral from a to b, square root, 1 plus dy dx squared dx. So to use this formula, I need dy dx, and my y is sine 3x, and so that derivative would be 3 times cosine 3x. And so I'm just going to substitute this into the arc length formula. 0 to pi over 6, square root of 1 plus 3 cosine 3x squared dx. And if you look at your answer choices, nothing matches that exactly, but you can see there is one choice where this 3 here has been squared to give us 1 plus 9 cosine squared of 3x dx. And so that's our answer, answer D. Okay, on question number 3, we have this graph here with the equation given to us. And this is not a function, but we're asked to find the volume of a solid created with cross sections that are semicircles. So my cross sections, and they're running perpendicular to the x-axis. So here's a representative rectangle for one of those cross sections. This thing that I've drawn here would be, the diameter of our semicircle. Now to find the volume of the solid, of course our formula is integral area of the shape dx, and since our shape is a semicircle, then we're going to integrate pi r squared over 2, the area of the circle divided by 2 dx. And so in order to fill in this formula, I need to find an expression for r. Now the rectangle that I drew in, it gives me the diameter. The radius of our semicircle is of course going to be half of that, or this section right here. The length of this part is just going to be whatever the top of our graph is to the x-axis, to 0. So let's look at the equation that we're given. And I'm going to solve this for y. Y to the 4th over 81 is 1 minus x to the 4th over 16. Multiply by the 81. And then take the 4th root. Now when we take the 4th root, of course we have to remember there's going to be a positive and a negative 4th root of all of this. So the positive portion of our root is the top part of this graph, and the negative portion is going to be the bottom part of the graph. So you can see that our radius, the length of our radius is really just the top part of the graph of this function, or the positive part of this equation when we solve for y. So I'm going to write my integral. Let me try that again. Volume is the integral from -2 to 2. Those are our intersection points over here, -2 to 2. Pi times r, which is going to be the positive 4th root of 81 times 1 minus x to the 4th over 16. That whole thing is squared, and that gives me the whole circle, but I want a semicircle, so I divide by 2 dx. And then you can see from the answer choices here that this is a calculator question, and if you type this into your calculator very carefully, you should get the answer 49.425. All right, let's move on to question number 4. A vase has the shape obtained by revolving y equals 2 plus sine x from x equals 0 to x equals 5 about the x-axis. What is the volume? So I'm going to start by sketching this graph. If this is 2 plus sine x, then my graph would look something like that. And I'm going to guess 5 is right about here, because of course getting to this point would be 6.28 or 2 pi. So here's my region that we're going to rotate around the axis. That's a terrible reflection, but maybe you can imagine what this vase would look like. You can see that there's not going to be a hole, and so our formula is pi big R squared dx, because it is a solid of rotation with no hole. So the volume is going to be the integral from 0 to 5 pi. My big R is obviously the function 2 plus sine x squared dx. Again, this is a calculator question, and if you type that into your calculator, you should get a volume of 80.115. All right, finally, we're going to look at this free response question on the back. We have this region given to us, bounded by the x and y axis. We have this function, e to the 2x, and a vertical line, x equals k, that's finishing off the region. For part A, we want to write but not evaluate an expression involving an integral that gives the perimeter of R in terms of k. So to find the perimeter of this region, I notice I've got 3 straight sides, and then I do have this one side over here that is a curve. To find that part, we're going to use our arc length formula for this part. But for all the other sides, we can just look at our graph here and tell how long they are. This side here has a length of 1. This side is a length of k. This one, e to the 2k, which we can see from our y coordinate here. And so the last piece that we need is the arc length. So we're going to use that formula. Integral a to b square root 1 plus dy dx squared dx. In order to do that, I need my derivative. dy dx is going to be the derivative of e to the 2x, which of course would just be 2 times e to the 2x. So I'm just going to go ahead and go straight to the expression for perimeter, which is going to be the integral from 0 to k. Those are the x values that form the boundaries on my arc there. Square root of 1 plus 2 e to the 2x squared dx. So that's going to give me the arc, and then I'm just going to add on these other 3 sides. Plus 1 plus k plus e to the 2k. And that expression would give us the perimeter. All right, next part. The region R is rotated around the x-axis to form a solid. Find the volume in terms of k. All right, so if we're rotating, and I'm rotating around the x-axis, then I'm not going to have a hole. And so again, my formula is just pi big R squared dx from a to b. So my volume is going to be the integral from 0 to k. Those, again, are my x numbers that provide the boundaries. Pi times the radius, which of course is going to be just our function, e to the 2x squared dx. Now on this question it does ask us to find the volume, so we need to actually evaluate this integral. To do that, I'm going to rewrite it as pi times e to the 4x dx, because that's 2x squared, so I'll multiply those powers. And then when we integrate this, the pi is just a constant, so it's going to stay. And then when I integrate e to the 4x, we're going to do a u sub, where our u is 4x, which means my du would be 4, so I'm going to multiply times 1/4, and then e to the 4x. And we want to evaluate this from 0 to k. So the pi times 1/4, I'm just going to make that pi over 4, e to the 4k minus pi over 4, e to the 0. And of course e to the 0 is just 1, so we have pi over 4 e to the 4k minus pi over 4. And that would be the volume of the region in terms of k. All right, our last question here, the volume V found in part B changes as k changes. If dk dt is 1/3, determine dv dt when k equals 12. So I know it's been a while, but hopefully you recognize this as a related rates problem. And we're asked to find dv dt when k equals 1/2, given this is our other rate that's given, dk dt, which is 1/3, and then we need an equation. And our equation, of course, is going to be the volume that we found in part B, which is pi over 4 e to the 4k minus pi over 4. So now what we need to do is take a derivative. The derivative of v dv dt. The derivative of our next term is going to be pi over 4 times e to the 4k times 4. But don't forget that we are taking a derivative with respect to time, so we need to do times dk dt. And then minus, and the derivative of pi over 4, which is just a constant, so that derivative would just be 0. And to get our final answer for dv dt, I'm going to substitute in values here. Pi over 4 times e to the 4k, which is 1/2, times 4 times dk dt, which was given as 1/3. And of course this answer would be fine for free response, but if you do want to simplify, I'll go one more step. We'll divide out those 4s. I'm going to make this pi over 3 e, and then this 4 times 1/2 would just become a 2. Pi over 3 e squared.